Hello, my name's Kevin Large and I'd like to welcome you to the 6th in our series of IoT security Raspberry Pi emulation videos. In this 6th foundational video, we'll be creating a Qemu virtual machine. That is to say, we're going to create our first emulated Raspberry Pi. Now I've tidied up the downloads folder, so it now only contains the two pieces of software that we actually require for this particular session. They are the PL app image zip file and the kernel Qemu 4.434 Jessie kernel image. What we now need to do is we need to extract the zip file. We'll just double click on the zip file. We can see there's the chestnut image inside, which is a modified version of Raspbian, which is used by the Cisco IoT security curriculum. We'll go to extract all. We can leave it at the default location for the extraction process and then just click on extract. Okay, this will take a little while, so what I'm going to do is I'm just going to pause the recording for a second or two. Once the files have been successfully extracted, you can see the chestnut image, chestnutinfo.txt file, a readme file, a PL app file, which the only file we're actually really interested in is this one here, chestnut.amg. Okay, so that's the extraction process done. I'm just going to go back now. You can see the zipped file, the kernel image that we had before, and now the extracted file. What we now need to do is I'm going to go back one and we're going to create a folder for the software that we're going to use to run our emulated Raspberry Pis. We'll need to create a folder for each Raspberry Pi that we emulate. So if we only want to emulate 3 Raspberry Pis, we'll just need to create 3 folders. I'm just going to create one to start off with. I'm going to right click, go to new, folder. I'm just going to call it node 1. And in the node 1 folder, I'm going to copy the kernel image. So right click, copy, and paste. I'm also going to copy across from the unzipped PL app image the chestnut image folder. Copy and back into node 1, paste. Now this is a big file. I do have an SSD drive in this laptop, so it comes across relatively quickly. It's unfortunate really in a way, but every emulated Raspberry Pi that you create, you will need to put a separate chestnut image. So if you create 3 Raspberry Pis, you'll need 3 folders, each with their own chestnut image in. Okay, so we've got the operating system image, we've got the kernel image. The next thing we need to do is we need to create a text file and a Windows batch file. The first thing we'll do is we'll create the text file. The text file needs to be called chestnut.txt. So I'm just going to right click, go to new, go to text document and type in chestnut.txt. The txt is already on the end. If you can't see the extensions, all you need to do is go to view and make sure that you've got file name extensions ticked. Okay, and that will allow you to see the extensions on the files. In the chestnut.txt file, I'll double click on it to open it in Notepad. We need to type in device underscore name equals double quotes and inside the double quotes you just put the name of your device. So I'm going to call this Qemu RPI1, and this will be the host name of our emulated Raspberry Pi. That will be followed by device underscore password equals, there's no spaces here, again double quotes, and inside the double quotes we'll put the password. I'll make this TM357, and that's all there is to it. I'll hit Control S to save, and we're good to go. And what does that do? Well, that sets the host name on the Raspberry Pi, on the emulated Raspberry Pi. When it boots up, it will actually look in the folder, the /boot folder, for this file, and that will set the host name. It also sets the password for the PL app web interface. So if we use the PL app launcher to browse to the Raspberry Pi, or if we browse to it by IP address from a web browser, it will be the password we use there to get into the device. There's another file that we need to create now, and this is a bit more complicated. This is a Windows batch file. Now, Windows batch files might look a little bit scary, but they're not really. They're relatively straightforward once you get your head around what's actually going on. So what I'm going to do is I'm going to use the right click on the mouse, go to New, create a new text document, and I will call this start.bat. Okay, so you need to make sure that you can actually see the file name extensions, and you need to change the file name extension from .txt to .bat. That's critically important. It can't be .txt.bat or anything else, it's just got to be .bat, and this will indicate that it's a batch file. Start.bat. It will warn you that if you change your file name extension it might become unusable, but that's fine, we know what we're doing. Now you've got to be careful now, because this is now a batch file, and if you double click on it, it will try to run it because it recognizes the .bat extension. However, what we can do is we can right click on the file and we can go to edit, and in here there's quite a lot of information we need to put in. We will supply you with this information. We'll supply you with a batch file, but let me just go through precisely what's here. You could actually pause the video at this point and very carefully type it in, but we'll supply you with this. It's a tiny little file. Just going to save that with Control S. When we installed Qemu back in Foundation video number 2, it was put in program files Qemu, and the executable is Qemu system arm.exe. This little symbol here, which is like an inverted V or sort of a roof of a building, this just basically means that the lines below are actually not new lines, they're all part of the same line. Believe it or not, this is a very, very long command. It's all one line. This just allows us to put a one-line command into Notepad, where we actually have them down on lines, new lines, one above the other. Okay, so this is a single one-line command. -kernel indicates the kernel image that we're using, so that's a kernel Qemu 4434 Jessie. CPU indicates the type of processor. Now the Raspberry Pi of course uses the ARM processor, the Advanced RISC Machine type processor, so it's an ARM 1176. -m is the memory, and that's 256 meg of RAM. Now be careful here, don't be tempted to try to put more memory in. Qemu will only work with a maximum of 256 meg of RAM for this particular model of image, which is the versatile PB image indicated by the line below, and that's the model that we need to use for the emulated Raspberry Pis. So though it would be nice to perhaps put 512 meg or perhaps 1024 to bring it up to a gigabyte, you cannot do that. 256 meg is the maximum amount of RAM you can use, and a Raspberry Pi will actually run perfectly well, an emulated Raspberry Pi in 256 meg of RAM. Serial standard input output, we won't worry about that. Append root dev SDA2 is basically saying where the root of the file system is. This is SDA, which is the second partition on the first hard drive. It's an ext4 formatted file system. read-write access. HDA is indicating our operating system image, which is of course the Chestnut image, which is in the same folder. NetNIC basically says that we have a network card. The network card is the TAP net adapter. This was in foundational video number 5. ID net 0, IF name VME1, or whatever you called your TAP Windows adapter. This is why we changed the name from local area connection 1, 2, 3, etc. to something nice and short, and preferably with no spaces in. Scripts no, down scripts no, don't need to worry about those, just make sure you put it in there. And then finally the MAC address. Now the MAC address has to be unique for each individual Raspberry Pi that you create. Understandably, the MAC address for each node on a network segment does need to be unique. Don't make the mistake of tapping in any old MAC address you feel like here. I actually did that when I was practicing doing these videos, and I accidentally guessed a multicast MAC address, which stopped Qemu from running in the first place. That caused a bit of scratching of the head. So I'm using 001501101011, and if I want to create another emulated Raspberry Pi, I will just put, instead of 11 on the end, I'll put 12, and that finishes off with no reboot. Okay, so there's our batch file. That's created, it's saved, we can close the window. There should be everything we require now to run Qemu. However, there is one critical thing that we need to do. This Chestnut TXT file has to be put inside the operating system image file. Otherwise the operating system image file will not run correctly. How do we do that? This is where OSF mount, digital forensics software, comes in. Okay, so what I'm going to do is I'm going to run OSF mount as the administrator. Run as administrator, accept the user account control, and then all we need to do is go to Mount New, Disk Image, locate our disk image with the 3 dots. That will be in Downloads, Node 1, Chestnut IMG, in other words, this image here. Next, there are 2 petitions. One is the /boot petition, the other one is the root petition. Just like on any Raspbian operating system, including the ones that go on SD cards of real Raspberry Pis, you have a /boot petition and you have a root petition. We're interested in the first petition, petition 0, the /boot petition. So we'll click on that, and next. This is digital forensics software, so by default it mounts in read-only mode so as it doesn't corrupt or damage the data in any way. However, we wish to write to the image, so we need to untick read-only and then mount. Now if your computer has a CD-ROM drive in it, which will be the D drive, it will mount it as an E drive, the next letter. If your computer has no CD-ROM drive, then it will probably mount it as a D drive. Once it's mounted, we can actually double click here, and we're now inside that Cisco PLApp operating system image. We're inside the /boot petition. In fact, if I go to View and I click Show Hidden Files, these are the firmware files inside the Raspberry Pi, or in this case slightly modified Raspberry Pi image, the Chestnut image. Okay, I'm going to deselect hidden files, and what we need to do is we need to copy across our chestnut.txt file and drop it into a mounted Chestnut image file. Okay, we can have a little look in there just to make sure everything's okay. So device underscore name equals quotes Qemu RPI1 end quote. Device underscore password equals quote TM357 end quote. So that all looks good. While we're here, we can do a little trick. There's a nice little trick we can do. We can right click, we can go down to new text document, and we can create an empty file just called SSH with no extension on at all. Just remove the extension completely. An empty file called SSH, and what that will do is, let's accept the change. That will cause the Raspberry Pi, when it boots up, as soon as it sees that there is an empty file called SSH in the /boot directory, it will enable the SSH server on the Raspberry Pi, which will allow us to SSH into the device remotely. So that's quite a nice little move. Okay, now at this point we can close the E drive, and then it's just a case of dismounting the virtual hard disk. So we can hit dismount and then exit. Highlight the partition, dismount and exit. And now comes the fun part. The only thing remaining to do now is to start your emulated Raspberry Pi. And we can do that by double clicking on the start.bat batch file. This will throw up a little command prompt window which indicates the command that was being run, and it will also start up Qemu, and there is Qemu loading. Okay, I'll just minimize the command prompt window. Don't close it, just minimize it. And you can see that it's emulating a Raspberry Pi with just one processor core, or one processor, as we've got the one Pi there. You can see the variables and services starting up. It's not super fast, but the key thing is it works. Now you'll notice it's just found the Qemu hard disk drive, Cisco PL app. It's mounted the /boot folder. On the first time you boot up your emulated Raspberry Pi, it may well get to about a minute or so, minute and a half in, and it will throw up on the screen a little box with a green line on it saying this operating system is not mounted on an SD card and you need to reboot. Just leave it. It will leave it a few seconds and it will actually reboot all by itself, and on the second reload it will work fine. So if you should find that on the first reload, on the first boot up, it throws up that little green line saying you know, the image is not on an SD card, just leave it to reboot. The system will reboot once, and then on the second reboot it'll run fine. And there you go, it's loaded. And not only has it loaded, but because we have the emulated Raspberry Pi connected to a Windows tap adapter, which is bridged to the Windows bridge, and the Windows bridge has my wireless network connection connected to it through internet connection sharing, we've even got an IP address of 192.168.137.182, and that's come from the Windows internet connection sharing. Let's just see if we can show you what's going on here. You'll notice that VME1, which is the tap adapter that this Raspberry Pi instance is connected to, is actually connected now, as opposed to VME2 and VME3, which you can see the red crosses, they're not connected. Okay, we've got a working Raspberry Pi. I'm going to type Pi and Raspberry, and we're in. Okay, this is a slightly longer video. You can see that SSH is enabled because we created that empty file called SSH in /bin. We can do a quick bit of testing. We can do an IPA, have have a look at the IP address on the Ethernet 0 interface, 192.168.137.182, which it's got from the internet connection sharing, which acts as a DHCP server. You can use the older command, ifconfig. We can type ss-tln, which is socket statuses for TCP listening sockets, numerical, which will show us that we've got port 80 and port 22 up and running. And with port 22 up and running, we should be able to SSH into the Raspberry Pi. Of course, the old command for that would have been netstat, for instance, netstat -pant. P for processes, who owns the process, A for all, N for numerical, and T for TCP. And if we remove the N, you'll see that it does actually say HTTP and SSH. And you can do the same thing, of course, with the newer SS command. There we go. So there you go, one emulated Raspberry Pi. Now I'm going to do a sudo su to become the root user, and I'm going to power off. When I power off, if you have a little look at the VME1 adapter, when I completely shut down this Qemu instance, you'll see that it disconnects that adapter. Okay, so what I'm going to do is I'm going to do a Control-L to clear the screen, and I'm going to type power off. So you've created your first emulated Raspberry Pi, and we can make as many of these as you like. If you've got enough hard disk space, you could make 3, 4, 5, however many you like. Just need to make sure that you change the MAC address and obviously create enough Windows tap adapters. When you shut down, you will always get this kernel panic right at the very end. However, that is after it's reached the power off target, so the system has actually effectively shut down perfectly now. The system has halted, and then you get the kernel panic, so it's absolutely no trouble whatsoever there. Again, this is experimental software, but the kernel panic doesn't happen until after the system shuts down. It seems to be remarkably stable. It's just a case of when I close this window, you should see the red cross pop up on VME1. There we go, and we're ready to go. Okay, slightly longer video that one, so I'll stop this one now. And join me for the next video, where we'll customize a Qemu virtual machine emulated Raspberry Pis. Thanks for joining me.